So in this example, we're going to take a look at how to build a marketing campaign and collaborate with the data science team. So we have a bunch of sales data from our online retail storefront. Historically, this data was exportable in an Excel spreadsheet. So we have some old data that's in Excel, about 500,000 rows. And then more recently, we've moved to a new online storefront, and the data is exported in JSON format. We have several million rows of data there, several million transactions. So what we're going to do is show you how to clean this data up, prepare it for use in data science modeling so that we can create a campaign and forecast sales going forward and create a surprise and delight campaign for our customers with help from the data science team. So the sales and marketing team have firsthand knowledge of these systems and the data that we want to pull together, while the data science team have all the tools and capabilities to build out an accurate forecast and model for us. So let's take a look at how these two teams can work together in the cloud. We'll start with some data preparation in Gigasheet. Gigasheet is a big data spreadsheet that makes it really easy to work with huge data sets, whether it's CSV and JSON and Excel files like we're going to look at today, or you're pulling in data from data warehouses or data lakes or cloud storage applications. Basically, anyone with spreadsheet skills can get started with Gigasheet and do data manipulation, data preparation, and exploratory data analysis. Once we prepare the data and pull the right data together, we're going to hand it off to the data science team. We'll be using Einblick. Einblick's cloud-based Python notebooks provide a multiplayer experience where it's really easy for groups to collaborate and code together and pull together models, and in this case, a forecast. So we're going to take a look at that. Cool thing about this is both of these products are free to get started with, and you can sign up on Einblick.ai or Gigasheet.com. Get going. Let's dive in. So let's take a look at our data and do some exploration to get started. I'll start with an Excel file from our original system. I'll just drop it into Gigasheet here, and we can see it processing. So we'll take a look at the data that originally was stored in Excel for our online sales transactions, and we're then going to also take a look at a dump of data in JSON and see how that compares. I zipped it. This is actually quite a large file. You can see here, even zipped, it's 163 megs. So we'll let that go. The Excel file I dropped on is now been processed as well. You can see it has just over 500,000 rows, 542,000 almost. We'll take a look at that. So this was the transaction data. We can see here we've got the invoice number, stock code, all the columns over here. Pretty basic stuff. We've got some prices and customer IDs, countries of origin, or where we were shipping to. So pretty cool. So what I want to do first, before we hand this off to the data science team, is get all this data together and consolidated into a single unified data set that they can then take and do some analysis on for us. The data science team is going to run some analytics and models and suggest an outbound marketing campaign that we could launch and target our best customers. But to do that, we really want to have data, a comprehensive set of data from both our old system and our new system. So the data from the old system was exported into this Excel spreadsheet, and the data from the new system is being processed now. It comes out of the database in a JSON format. So I'll give this a second to run, and then we'll take a look at how it compares. Okay, the data is processed, so let's take a look at this JSON file here that's been dumped for the Einblick project. We can see here it has a number of different columns as well. The columns are on the right again, and we can tell that it looks pretty similar. If we just scroll across here and look at some of the data, slightly maybe different formats. What we want to do is combine this. So you can see here from the database dump, we have 4.2 million records that we want to analyze as well. So the first thing that I want to do is combine these two files. So first of all, I've got 12 columns here and 9 columns here. So we'll need to make these consistent. When I take a look at the columns in both files, I can try to determine what the difference is, and I'll just eyeball it pretty quickly here. So one thing that stands out is the transaction hash column. So I'll get rid of that. And then it looks like stock code is in here as well. We've got this customer cohort, which is also unique to this file. And we have this field called completed guide. Those aren't really important for the analysis, so I'll hide them in this case. I also need to rearrange these columns so that they align with the original file. I'm just basing it on this one because it's a little easier to do. Okay, now it looks like this data is nicely aligned with this. So what I'll do is File, Save As. Now that's created a new file here in the library for us. So that'll take a second. Now we have both of these have 9 columns, and let's just check to make sure that it did it properly. Looks good. Now let's combine these two files. And now we can see we have 4.8 million rows and 9 columns. So this is the data set that is now ready for analysis by the data science team. So I will go ahead and clean this up here and delete the original files, just for housekeeping purposes. So this is great. So we have this file, it's 4.8 million records, and it has our 9 columns here. And the next thing I want to do is check for duplicates, because we ran both systems in parallel before we cut over to the new system, the database. So I'll use the remove duplicates feature in Gigasheet, and I'm going to do this on all of these because I want to check for exact matches across everything. So it actually identified 5,500 some odd duplicates. So I'll go ahead and remove those. Nice. So before I share this with the data science team, I want to actually limit these invoices to a certain date time range. So what I'm going to do is build a filter in here to specify 1 year of data that I'm interested in. In this case, I'm going to jump back to 2010. And I want to look at December 9th, and then I'll jump to December 9th the same year, a year later. So we'll hit apply. Now we're down to about 515,000 records, and I think it's in good shape. So I'll hit share and give access to the data science team.
Now that the dataset has been prepared, I'm ready to bring it into Einblick. The first thing I need to do is to install the Gigasheet API. I do this by using pip install and going to the GitHub repository where the package lives, importing the package, and then instantiating the connection using an API key. You can safely store your API key in the Secrets tab of the Einblick workspace. Once I'm connected to Gigasheet, I can now specify my Gigasheet handle, which is available in the URL of the sheet itself, use the create export current state function to create an export, wait for that file to finish, and then use the download export function in order to generate a URL where I can access the file. With this file, I'm able to use the zip file package and read that into a pandas data frame. Within Einblick, we offer a range of functions, including the table operator, which allows you to preview the dataset. I do notice that invoice date is a text column instead of a date column, so the first thing I'll do is convert that into a date column. I do this by creating a Python cell, and then going ahead and using the toDateTime function with a certain date format. Now, when I preview the table, I can see that invoice date is properly a date. I just want to quickly look at the quantity sold over time, so I grab the header of the invoice date. Then I specify that the y-axis of this chart should be the sum of quantity. And I can see that there's generally an increasing sales trend over time. December is probably not complete in this data set, and I can kind of see also a seasonal pattern where maybe I have a little bit of stronger sales heading into the holiday season. I can view other outputs as well. For instance, I can go and see the number of units sold by country. I see here that the United Kingdom makes up 91% of our sales. I'm also going to go ahead and make a histogram of the unit price column. I'll drag that out onto the canvas and see that the vast majority of items sold have a unit price of less than 5, though I have some more expensive items in here as well. We can go and put a zone around this data exploration, so we can mark it as some charts. We use the data zone operation, and we'll set the color to purple, title it Some Charts. But for the actual analysis that I want to do, I want to forecast the sales of a single item. In this case, I'm going to forecast the sales of my top item. To do that, the first thing I'll do is create a Python cell, and I'll group by the description and get the sum of quantity and sort the values. I see that World War II gliders have the largest quantity sold, and I'm going to go ahead and take another branch of this analysis where I filter for just the description equal to the World War II gliders assisted designs. And I can now preview the results of that using a table. The first thing I want to do is illustrate what the quantity sold over time is. I'll do this by dragging out the invoice date column, changing the x-axis to be aggregated by day, and the y-axis to be the number of quantities sold as a sum. I'll take this as a line chart. I notice that most days make a lot of sense, but I have some outlier dates. Forecasts can be pretty sensitive to outliers, especially if I don't think they can be relied upon. And so what I might go ahead and do is to eliminate the dates that have too high and too low values. I first need to create a data frame where the values are grouped. I take the input and say df ww2 to differentiate it from df. And then I do a group by in order to get the quantity as a sum per day. And then again, rename it to be ds and y, which will be future requirements for the profit package. I can see that now I have ds and y, but I know that I want the dates to be less than 2000 and greater than 0. So I'll go ahead and make another Python cell, and I'll ask the AI assistant to simplify this code for me. Remove rows of df where the value of y is greater than 2000, and also remove rows less than 0. Now I'm ready to use the profit package. I'll make another Python cell, and the first thing I'll do is pip install profit and instantiate the model. Since I don't care about the outputs, I'll go ahead and click input only mode. Next, I'll actually set up profit. I'll fit the model to my data set, and then I'll make a forecast for 365 days out. Once the forecast has been made, I can go ahead and preview that forecast as a table. And I can grab the y-hat column, which is the predicted volume column. I'll set the x-axis equal to invoice date, which is now named DS. And I'll set the y-axis equal to the sum of y-hat. Here I see that it believes that there's an uptrend that should be continuing, and it does taper us out a little bit and shows a little bit of seasonality. We can actually make use of some of the explainability tools already built into the model, and we can go ahead here and use the model.plot components to see what the model actually decomposed it as. We think that there's an uptrend over time. We see that there's weekly seasonality. We see there's annual seasonality. Another great forecast explainability tool is using the Plotly package. Here we can use the Plotly model forecast, and we can see that this is the performance over time. Once I'm happy with the forecast, I can tune some of the other parameters, but I'm going to go back to the Gigasheet API. The first thing I need to do is to write a CSV to our local file system, and then I'll use the giga.upload command in order to upload it. I'll go ahead and hit execute here, and we'll see that it was uploaded with the handle, and I can now pick up that forecast and use this table in Gigasheet. Of course, I could have done some of the renaming and data cleansing here, but I can also do that in Gigasheet as well now.
I got a notification in my email that Paul and the Einblick team has shared a file with me, this forecast.csv. So let's take a look at the results. Cool. I can see here we've got 16 rows of data and a bunch of different transactions based on the data science team's feedback. This is who we should run our surprise and delight campaign with. But this isn't really useful. I have got these customer IDs, which I have not memorized, and I want to do a lookup to figure out who I should contact. So what I'm going to do is upload another CSV which has all the ID numbers for our customers and drop that in, and that will process. We'll take a look at that, and I'll show you how that we can do a cross-file lookup to pull in the actual customers' names. So here's the company, their mailing address, and then the customer IDs we've got in here as well. What I'd like to do is do a join and pull that stuff in. So I'll do that real quick here. I'll use our cross-file VLOOKUP function to select the primary key, the field I want to match on. In this case, it's customer ID. I want to browse to our customers file that I just uploaded. I want to pull in a match on customer ID here. It's named slightly differently. In this case, I know they're exact matches. If we were matching on things where we wanted to do more of a fuzzy match, I could use the near match, but in this case, I'll do that. And I want to bring across some values. So I want to bring across the address and also the company name. So I'll hit apply, and basically this will do a lookup to that other sheet and bring in the data. Awesome. Now I know who to ship my presents to for our marketing campaign. So that's how you can use Gigasheet in conjunction with Einblick to combine data science power with the ability to work with big spreadsheets online. Thanks, and I hope you sign up at gigasheet.com or einblick.ai and check it out.